Today we're going to begin Topic 3, Integer Exponents. We're going to start with Lesson 3-1, Perfect Squares, Square Roots, and the equations of the form x squared equals p. We've introduced perfect squares, we've talked about square roots. This is just going to be taking it to a new level. I'd like for you to read the essential question. Measurements frequently involve very large or very small numbers. How can you make such measurements easy to use and to compare? Your friend claims that x squared is the same as 2x. Tell how he could have come to this conclusion. Explain whether or not you agree. There's two cards. One is x squared and one is 2x. Try a number other than 2, because 2 is going to work, to either prove or to disprove your friend. So if you pick 3, for example, if x equals 3, then x squared is equal to what? 9. And if x is 3, 2x is going to be equal to 6. X times x is x squared. X plus x is 2x. So if you said your friend was not correct, you were correct. X squared and 2x are not the same thing. Here's your focus question. How can you apply what you know about squares and square roots to write and solve equations of the form x squared equals p? How can you use equations in that form? Here's the first of some key concepts. First is perfect squares, the definition. A number that is the square of an integer is a perfect square. Two squared is written to exponent 2. It's equal to 2 times 2, or 4. 3 squared, 3 times 3, or 9. 4 squared, 4 to the power of 2, is 4 times 4, or 16. Now, think about negative numbers. Negative 2 squared is also 4. Negative 3 squared is also 9. And negative 4 squared is also 16. The next key concept, square root, the definition of which is the square root of a number is another number that when multiplied by itself is equal to the original number. Clear like mud, right? It's a good thing you already know that definition. However, in this program, the square root sign, which you also know is called the radical sign, means the positive square root of a number. Unless it's otherwise stated, that's what that sign is going to mean. So the square root of 4 is equal to 2. Why? Because 2 times 2 equals 4. Square root of 9 is equal to 3, because 3 times 3 equals 9. The next key concept is the relationship between squares and square roots. Squaring a number and taking a square root are inverse operations. So here we have 3 squared is 9, so 3 is the square root of 9. So when you look at the little diagram, on the left you've got 3. If you square 3, you get 9. However, you take the square root of 9, following the red, you end up back at 3. Next we have the number of solutions. Typically when we see x equals something, we think that there's one solution, and only one solution. What does x squared equal p mean? If I put a value of 4 in for p, then we're asking what does x squared equal 4 mean? We know that 2 squared is 2 times 2, which is equal to 4, and negative 2 squared, which is negative 2 times negative 2, is also 4. So as far as the number of solutions, x is actually equal to both 2 and negative 2. Please note the way this is going to be written. When there are 2 solutions, x will equal plus or minus 2. For a more generalized application, consider the equation x squared equals p for any value where p is greater than 0. The square root of p squared is equal to the square root of p times the square root of p, which equals p. And with the negative sign outside, the square root of p squared is equal to negative square root of p times negative square root of p, which is also equal to p. So we have both the square root of p and the negative square root of p. So x is equal to plus or minus the square root of p. It goes on to say, in general, an equation of the form x squared equals p when x is greater than 0 will always have two solutions, one positive and one negative, written the exact same way, x equals plus or minus square root of p. Solving equations. Next we have solving equations containing squares. To solve an equation of the form x squared equals p, you need to take the square root of both sides of the equation. Our example is solve x squared equals 100. Write the equation. We're going to take the square root of both sides. Simplify the square roots. The square root of x squared is x. The square root of 100 is a positive and a negative 10. So there's our answers. The solutions are positive and negative 10. We of course check our answers by putting those back into the original equation, coming out with both 100s. Let me get it. Next we have 4 equations that we need to solve. It says to solve each of these equations, we take the square root of each side of the equation, which is what we've just previously finished doing. Equation A, x squared equals 4. Take the square root of both sides. So x is equal to plus or minus square root of 4, and we know that to be 2. So our solutions are positive and negative 2. We can take both of those numbers, plug them back into x in the original equation, and they will both work. B, x squared equals 81. Again, take the square root of both sides. So we end up with x is equal to positive or negative square root of 81. So our solutions are x is equal to positive or negative 9. Plug those back in and they will both work. Letter C, x squared equals 49. Square root of both sides. We end up with x is equal to positive or negative 7. Those are both the solutions. And letter D, x squared equals 16. Same type of deal. Take the square root of both sides. Our solutions are 4 and negative 4. Okay, based on what we just did, given y squared equals 625, how would you solve that? Using the exact same steps that we just did. Take the square root of both sides. So y squared equals 625. Take the square root of both sides. Y is equal to positive or negative 25. We take those two solutions, we plug them both in, make sure they both work, and of course they do. Here's another example. Solve a squared is equal to 64 over 81. The steps are listed there. Hopefully you're looking at 64 and 81, knowing that they are both perfect squares. What we start with is writing the equation. Take the square root of both sides. Simplify. Square root of 64, 8. Square root of 81 is 9. Positive or negative. So there's our solutions. We check our answers and make sure that they work. And they do. y squared equals 4/9. We're going to write the equation. Next, we're going to take the square root of both sides. We're going to simplify the square root, knowing that the square root of 4 is 2, and the square root of 9 is 3. There's our answers, positive and negative, 2/3. We will plug them into the original equation, and they will work. Okay, here's a rather challenging example. A company makes small custom designed stamps that have a square image area. Keyword there is square. The image area has an area of 1200 millimeters. Keyword there is area, which you all know is length times width, but when it's a square, it's one side squared. What is the exact length of one side of this stamp? If your answer is not a perfect square, which is part B, approximate your answer to the nearest tenth of a millimeter. Let's start with A. Use the formula for the area of a square. A equals S squared. We're going to substitute 1200 because we know that's the area. So we have 1200 is equal to S squared. We're going to then take the square root of both sides. So now we know that the length of one side is actually the square root of 1200. What we don't know is, what is the square root of 1200? So we estimate that it's somewhere between 34 and 35. And this is after, obviously, we've tried a few numbers, but if we've memorized our square roots, you'll have a pretty good idea. So 34 squared is 1,156. 35 squared is 1,220. Obviously, it's a little closer to 35 than it is to 34. But if I add those two numbers together, 1,156 and 1,225, and I divide by 2, my answer is 1,190.5. What does that represent? Approximately 34.5. It's just a little under, so we're going to move up to 34.6. You're going to try the math, and you're going to find that 34.6 is in fact your answer. All right, let's try one more problem. A square painting has an area of 460 centimeters squared. What's the length of one of the sides? Again, it's a square. We use the formula for the area of a square, that the area is S squared. So we're going to take the 460 and we're going to plug it in for area. We'll take the square root of both sides. Now we know that one side has a length of the square root of 460. Now, we have 441 is the perfect square for 21, and 484 is the perfect square of 22. 460 is right in the middle, a little closer to 21 than it is to 22. If I add up 441 and 484 and divide by 2, I get 462.5. So 462.5 compared to 460, we're right there. That's 21.5. That's our answer. You're not going to get much closer than 2.5. Perfect. We weren't exactly done, but these are the last problems that I would like for you to do and bring with you to class on Monday. Have a great weekend.